This is lecture 26 and we'll be doing the questions based on the maxima and minima. We'll be identifying the maxima and minima at given points, local maxima and local minima. And of course, we'll be also inspecting about the saddle points if it is there. We have already discussed the conditions. Let's start with the exercise 12.8 on, let's say we have question number 1. What it says that find the all local maxima, minima, saddle point. If any of these things are there, we just find it for this function. Okay, so what should be our first step?
Sir, f of x.
Yes, so our very first step is we'll calculate fx and we'll put it 0, we'll put it equal to the 0, and similarly we'll calculate this thing as well. So first of all, let's say fx. So fx is what? So differentiate this whole function with respect to x only and regarding y as constant. So that becomes 2x plus y, and derivative of y square would be 0, so plus 3, and rest of the terms will be 0. Is it fine? So yes, now we'll calculate fy is equal to 0. That means that becomes x plus 2y minus 3 is equal to 0. Is it okay?
Yes, sir.
Yes, sir.
So
Yes, sir.
Now we'll solve these equations, right? So we'll keep it like, just like we solve the linear equations. Okay, so let's say we multiply this second equation by 2, and now we subtract these equations. Let's say this is 1, this is 2, and 1 minus 2 gives y minus 4y minus 3y minus 3 minus 6 minus 9. So y is equal to what? 3. So if your y is 3, you can get the value of x as well. You put y is equal to 3 over here, right? So what do you get? X
minus 3
plus 6 is equal to 3. Yes, x is equal to minus 3. So we have only one critical point. Okay? So therefore, we have only one critical point. Minus 3 and 3. Is it fine?
So can we please switch to the previous page for just a second?
Yes.
Done.
Okay. So are you getting this? So now what should be calculated right now? Now we'll be calculating the second order derivatives. So fxx, right? So it is your fxx.
2y.
This is your fx, right? And what is your fxx? That is
2.
And what is your fyy?
2.
Again 2, right? So we need to calculate these fxx and fyy at this point. But since these two are constant, so at this point their value will remain same. That means 2 and 2. So this implies fxx at point minus 3 and 3 will be 2, and fyy at point minus 3 and 3 again will be 2. So now we'll be calculating fxy. So you already have fx, so we'll differentiate with respect to y, or you can also do that. You have fy, you can do it like differentiate with respect to x. So let's say we differentiate it with respect to y, so we are only left with 1, right? So here fxy at minus 3 will also be 1. So now, first of all, your fxx is what? Positive. Okay. So it can be a point of minima if we calculate the rest of the second expression, that is fxx fyy minus fxy whole square. So that is what? 2 into 2 minus 1. So that means 3, which is positive. So both these conditions are satisfied, right?
Yes, sir.
This is greater than 0 and fxx is positive. So therefore, 3 and minus 3 is point of minima, right? And if you're asked that find the minimum value, then what do? You just simply put this point into the function and you get the minimum value. Okay. So yes, f of sorry, I have just, it was a wrong point. I shouldn't.
So it is maximum.
It should be minus 3 and 3. It is minimum, right? The second derivative is positive, na? Positive something like concave upward, right? I told you, no? It's concave upward. So that means it can give you a point of minimum, right? Are you with me on this?
So but जो fxx, fyy और minus fxy का whole square है वो भी तो greater than 0 है.
वो दोनों केसेस में ही greater than 0 है. You can check this. इस केस में भी greater than 0 है, इस केस में भी greater than 0 है.
Okay, so okay.
Only this condition will determine if you get this thing positive, then you are only dependent upon fxx. If it is negative, then the point of maxima will come up. Otherwise, it will be a point of minima. Right?
Yes, sir.
Okay. So this is, we can also call it as Hessian, as I have told you. So if you want to find out the minimum value, so what do? You just simply put that point into this function and you will get that value. So that is f minus 3 and 3. So let's put this point. So minus 3 square, 9. Minus 3 into 3, minus 9. And then minus 3 square, 9. And then you have 3 minus 3. That means minus 9 and minus 9. And last you have plus 4. Okay. So this will get cancelled and you are only left with minus 5. So therefore we say that minus 3 is a point of local minima and minimum value is minus 5. Is it okay? There is a difference between the point and the value, right? So this is the point at which minimum value is achieved, and the minimum value which we get is minus 5. Is it okay? Yeah. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so let's move for the next question. Let's say question number 3. So let's say we have a function, and that function is 2xy minus 5x square minus 2y square plus 4x plus 4y minus 4. Right? So again, we'll be starting with the same ideas. So let's say fx0 and fy0. So this means fx, that means 2y minus 10x plus 4 is equal to 0, and fy means 2x minus 4y plus 4 is equal to 0. Is it fine?
Yes, sir.
So I'll rewrite it as minus 10x plus 2y is equal to minus 4, and 2x minus 4y is equal to minus 4. So let's say I multiply with 5, 10x minus 25 is equal to minus 20. Okay. So we can solve this, and this will simply add these two, right? Is it okay?
Yes, sir.
Yes, sir.
Okay. Okay. So let's add these 2 points. these two equations. So 1 plus 2 gives what? So this is your minus 10 and 10. So this becomes 0. Minus 20 plus 2. This becomes minus 18. So minus 18y is equal to minus 24. So this becomes 24 upon 18. So this becomes 4 by 3. Are you with me on this?
Yes, sir.
Yes, sir.
Okay, so let's put this value of y over here and we'll get the value of x. So this becomes 2x minus 4 times the 4 by 3 is equal to minus 4, right? So that is 2x is equal to minus 4 plus 16 by 3. So 2x 16 minus 12 by 3, which is 4 by 3. So your x is 2 by 3, right?
Yes, sir.
So the critical point is 2 by 3 and 4 by 3, right? Is it okay?
Yes, sir.
Okay, so let's move to the next portion. So we'll be talking about maxima and minima. So first of all, we'll be calculating fxx, fyy, and fxy. So let's say what is our fxx? So this is our fxx, that becomes minus 10, and fyy minus 4. So minus 10 and minus 4. And what about fxy? So this is our x. Let's say with respect to y, we have only 2. So since they are constant, so at this point they'll also remain same, right? At 2 by 3 and 4 by 3. Okay. So this is 2. So all these 3 are fine, right?
Yes.
Yes.
So we'll again calculate that expression Hessian, and so Hessian with us is fxx into fyy minus fxy square. So that becomes minus 10 minus 4 minus 2 square. So that is 40 minus 4, which is 36. So positive. So once Hessian is positive, so we are only dependent upon fxx. So our fxx is negative, and Hessian is positive. So what does that mean?
Maximum.
Maximum.
Yes. Yes. So therefore 2 by 3 and 4 by 3 is point of maximum. So similarly, you can find the maximum value, right?
Yes, sir.
Okay. So let's move towards the next question. Let's say question number 5. So we have fxy is equal to x square plus xy plus 3x plus 2y plus 5. So again start with the same thing, that fx0 and fy0. So fx0 means what? 2x plus y plus 3 is equal to 0. And fy0 means what? X plus 2. So yeah, x plus 2, right? X plus 2.
Yes, sir.
Yeah. So we don't have anything over here. Okay. So from here, we directly get that x is equal to minus 2. So if I put x is equal to minus 2 over here, so this becomes
1. Y is equal to 1.
minus 4 plus y plus 3 is equal to 0. So that becomes y is equal to 1.
1.
So therefore, minus to 1 is only critical point. Right? Is it okay? Are you with me?
Yes, sir.
Yes, sir.
Okay. So let's calculate the fxx, ffyy. So let's talk about this. So fxx. Okay, so
2.
what is fxx? That is 2.
2,
Fyy
1,
0.
0.
0.
Fxy
1.
1. Right. So fxx at minus 2 and 1 will be 2. Fyy at minus 2, 1 will be 0. And fxy at minus 2, 1 will be 1. So let's calculate the Hessian fxx fyy minus fxy whole square. So it becomes 2, 0, minus 1. So that becomes minus 1, right? So now this says that your Hessian is negative, and you know that. So we have done 4 cases. So this is our 3rd case when your Hessian is negative. So you don't care about any other thing. If your Hessian is negative, you simply say that your point is a saddle point.
Saddle point.
Your critical point is the saddle point. So therefore, minus 2, 1 is the saddle point. Right?
So means fx पर depend नहीं करेगा वो.
नहीं वो नहीं करेगा.
But
Hessian
पहले
नेगेटिव आते ही पॉइंट सैडल पॉइंट हो जाएगा. ठीक है?
Okay, sir.
Okay. So let's talk about few more questions. Why I'm saying that few more questions? Because there are few questions which are slightly different than the questions which we have already done. So let me talk about question number 18. Okay, so this is your question number 18. So we have a function which is equal to x cube plus 3xy plus y cube. So why this question is different? Can anybody tell?
क्वाड्रेटिक इक्वेशन बन जाएगी.
हाँ,
Yes,
तो
sir.
उसमें points ज़्यादा आएंगे, right?
Critical
So we'll
points
get
ज़्यादा
more
होंगे.
critical points. Yes, we'll have more candidates for the critical points than we used to have in our previous question, right? Is it okay? Fine. So again, we'll start with the same thing. Are you getting my voice?
Yes, sir.
Okay. So I'll start with the same thing, that I'll have fx, and that's what? 3x square plus 3y. Okay. And I have fy, that is 3x plus 3y square. So we'll keep these two things equal to 0, right? So let's try to solve it. So this becomes x square plus y is equal to 0. X plus y square is equal to 0. So value of x is minus y square, right? Are you with me?
Yes, sir. Yes, sir.
Okay. So let's put the value of x is equal to minus y square over here. So minus y square plus y is equal to 0. So that becomes y4 plus y is equal to 0. So that becomes y into y cube plus 1 is equal to 0. True?
Yes, sir.
Yes. So we have y is equal to 0 or y cube is equal to minus 1. So we have y is equal to 0 or y is equal to minus 1. So we have two choices of y, right? So now we have x is what? We have x is equal to minus y square. So once y is 0, so therefore x has to be 0.
Yes, sir.
And if your y is -1, so your x has to be -1.
-1.
So what are your corresponding points? Let's say if your y is 0, then your x is 0. So that means you have 0, 0.
0, 0.
And
And you have y
-1.
-1, then x is equal to -1. So that means what? You have -1,
-1, comma. Yes, sir.
Okay. So these are two critical points. So we have, so we'll say it as this and this are two critical points. Is it okay? Are you with me on this?
Yes, sir.
So we'll test these 2 points. Of course, we'll calculate the Hessian and double derivative if we need it. Okay. So we'll talk about these 2 points and we'll repeat the process for 2 points. Okay. So this time we'll repeat the process for these 2 points. So let's start with fx6. So what is your fx6? So this time it becomes
6x.
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 and what is your fyy?
6y.
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 Okay. So what is your fxy?
3.
3. 3.
3, right? So with respect to y, it is 3. Okay. So, right. So that's fine now. So let's start with the 0, 0 point. So first of all, fx6 at 0, 0, this becomes 0. And fx6, fyy at 0, 0, 0. fxy at 0, 0. This becomes what? 3?
3. 3.
So you calculate the Hessian, you will get what? 0 into 0 minus
-9.
So which is negative? So once your Hessian is negative, what would you say?
Saddle point.
Saddle point.
Yes. So since h is less than 0, therefore 0, 0 is a saddle point. Fine? Fair enough?
Yes, sir.
Yes, sir.
Okay. So let's check the next point. So next point is -1, -1. So fx6 at -1, -1. So this is your fx6 at -1, -1. It becomes -6.
-6.
fyy at -1, -1. So it
-6.
becomes -6. And your fxy at -1, -1. It is constant. So it will remain 3 over here. Okay. So we know that your fx6 at -1, -1 is negative. And what about h? H is -6
Positive
into
आएगा.
Positive 27.
yes. So
Maximum आ गया.
-3 square. तो ये कितना बन गया 27?
Yes.
Okay,
Yes,
which
sir.
is positive.
Point of maximum.
So therefore, -1, -1 is a point of maxima, local maxima, I would say. Okay. True? Are you getting this?
Sir, why we wrote local there?
Yeah, it is also local. So, it's a complete point. I would write it here also, local maxima. Okay? Yes, it's fine. Yes, you were saying something. पॉइंट इकट्ठा ही आएगा ना, ये देखो एक्स वाई का इकट्ठा ही आएगा. डोमेन का पॉइंट ही पॉइंट ऑफ मैक्सिमा या मिनिमा बनता है ना, तो इसमें डोमेन 2D है.
Okay, sir.
Is it fine?
Yes.
So this is our question number 29. Right. So the question says that we have trigonometric function in this y sin x. True?
Yes, sir.
Can you see that? Okay. So let's start with the same thing that we're gonna have fx. What is your fx? Y cos x. right? And what is your Fy?
Sin x.
Sin x.
Right. So you'll keep those things at, you'll keep those things 0. So first of all, you have y sin x is equal to 0. Sorry, y cos x. So first of all, you have y cos x is equal to 0, and then you have sin x is equal to 0. So can you tell me how are you going to solve it? How sin x is equal to 0? What is the solution of sin x is equal to 0?
N pi.
N by x.
N pi.
Yes. X is equal to n pi.
N pi.
Now what do? You put this value over here in order to get the value of sin x. So you're going to write it as y cos n pi is equal to 0. So y times minus 1 raised to power n is equal to 0. So what is the solution of this thing?
Y is equal to 0.
Y has to be 0, right? We don't have any other option. So y has to be 0. So the points we have, the critical points, are
N pi comma 0.
n pi comma 0, right? Okay, you with me?
Yes, sir.
Okay, so you have n pi comma 0. So now, so let's say starting with the fxx, fyy, and fxy. So what is your fxx?
Minus y sin x.
Minus y sin x.
Minus y sin x. Yeah, minus y sin x. And what is your f xy yy?
0.
Fyy 0, right? And what is fxy?
Cos x.
Cos x.
Yes, cos x. Fxx at n pi 0. So if you put x is equal to n pi, it becomes what? 0. So if you take f of yy at n pi 0, it is already 0. And if you take fxy at n pi 0, so it becomes what? Minus 1 raised
minus 1 power n.
Okay. So now if you calculate the expression, that is fxx into fyy minus fxy square. So this becomes 0, 0, minus 1 raised to power n square. So it doesn't matter what is the value of n, it will be always a positive one, minus 1. So this becomes, overall this becomes minus 1. So your Hessian is
Negative.
negative. So therefore
Settle.
n by 0 is a
Saddle point.
Saddle point.
Okay. So let's do the last question because we haven't done this kind of question. So once we do this question, we are done. Okay. I mean, this is slightly different question. So question number 30. And that's what? That is, you have f of x, y is equal to e2x cos y. Okay. So let's find out the fx first. What is fx? 2e2x cos y. And what is fy? Minus
minus sin
e2x
y.
sin y. Right? So I've taken that minus sign outside. So let's say we make it 0, 0. Okay. So 2e2x cos y is equal to 0. e2x sin y is equal to 0. Now what happens that we cannot get any solution for this. Why? So
We can add and square them.
No. Even then you cannot find that. Okay. So let me tell you how. Okay. So first of all, just solve this equation. So here you know that for any value e2x cannot be 0. Okay. So I was saying that let's you solve this equation first. Okay. So your e2x is always non-zero.
Yes, sir.
So your E2, once your E2x is non-zero, right? So your sin y has to be 0.
Yes, sir.
Yes,
Yes,
sir.
sir.
So once your sin y is non-zero, sin y is 0, that means your y is n pi.
N pi.
Now you put your n pi over there in order to get the value of x. But what happens? So 2e2x into -1 raised to power n is equal to 0.
E2x is 0, sir, but in this case.
Yes. So do we have any solution for this? Exponential cannot be 0, right?
Yes, sir.
Yes, sir.
Which doesn't give any real value, any real solution. So what should we say? Therefore,
No critical point.
No critical
there
points.
There's no critical point.
No critical point. Right? Is it okay?
Yes, sir.
Yes, sir.
So that's it for today.